In this video, we're going to work some problems using the formulas that we just had on the previous sheet. Okay, so here's two problems. And they want to know what is the pH. What is the pH to the hydroxide concentrations? There are two ways to do this problem. The first is to me more difficult, but I will show it to you first. And they're actually mathematically they're the same. It's just this has more pushing of buttons than the other one does. So I'm going to start with the Kw equation is equal to the hydroxide, the hydronium ion concentration times the hydroxide. And remember that Kw is 1 times 10 to the minus 14, and it's not given to you. So I have 1 times 10 to the minus 14th is going to be equal to the hydronium ion concentration, which I do not know, times the 4.83 times 10 to the minus 9th. I'm going to divide both sides by this 4.83, so I have 1 times 10 to the minus 14th divided by 4.83 times 10 to the minus 9th. Go back and look at this video, because if you enter this as times 10 to the minus 9th in your calculator without any parentheses, you will not get the correct answer. So you get H3O plus. So the H3O plus concentration is 2.07 times 10 to the minus 6th molar. And then to get the pH is the negative log of the hydronium ion concentration. So that's the negative log of 2.07 times 10 to the minus 6th, and I get 5.68. So that's method number one. I should have pointed out a little bit earlier that in this problem I am starting out with the hydroxide ion concentration and I'm going to pH. This is a two-step process no matter which way I go. So what I just did here was I went to hydronium and then to pH. The second way, as I told you, there's two ways to do this problem. The second way involves going from hydroxide to POH and POH to pH. So in the other method, change colors here to green. Okay. Like I said, so this is method number two, and I'm going to show you both methods. I'm going to suggest that you figure out which one is easier for you to remember and to stick to it and practice all your problems the same way. Either way is correct, so I don't care. So I'm going to start out with the equation that POH is equal to negative log of OH minus. And this formula, as I stated in the last video, is not given to you. So POH is the negative log of 4.83 times 10 to the minus 9th. And I get 7.32. The second equation I'm going to use is that the pH plus the POH is equal to 14. So pH, which is what I don't know, plus the 7.32 is equal to 14. So pH is 14 minus 7.32 to also give me 5.68. So it doesn't matter which method I use, I get the same numerical answer. I like this way. This is my personal preference. It's less typing. If you start entering, you have to enter this as 1 second E, or second comma to get the E, minus 14, and 4.83 second comma, or E, double E, minus 9, and then enter. Whereas this, you just have to enter the negative times 10 or the double E once in the equation. I highly suggest that you stop here and do the second problem on your own, and then use the rest of the video to check your answer. Again, there's two different methods to do this, the same two methods actually. So I'm going to be starting out, I'm going to do them in the same order. I'm going to start out with this equation. I'm going to start here where I plug it in just because of room. So I have 1 times 10 to the minus 14 is equal to the hydronium ion concentration times 3.2 times 10 to the minus fifth. So I divide both sides by the 3.2 divided by 3.2 times 10 to the minus fifth is equal to hydronium. So my hydronium ion concentration is 3.13 times 10 to the minus 10th. And then I'm going to use this I'm going to use this equation up here, the pH. So pH is equal to the negative log of the hydronium ion concentration, so 3.13 times 10 to the minus 10th, and that's equal to 9.51. So that's method number 1. Again, I can do it the same way as I did the other one. So this time I'm going to start with this equation. The POH is the negative log of OH minus, so POH is the negative log of this 3.2 times 10 to the minus fifth, and I get 4.49. Remember, as a check, if this is 5, I want this to be within plus or minus one value of 5, so 4.49 is. And then I'm going to use the equation of pH plus the POH, 4.49, is equal to 14. And so pH is equal to 14 minus the 4.49 to give me again the 9.51. And just to practice back to something else that we did earlier in this chapter, with a pH of 5.68, this is acidic. With a pH of 9.51, this one is basic. So just kind of a flashback to that. I have a couple more problems that can be done, and those will be in the coming videos.